Filming.
Alright guys, this here is my circuit diagram of the radio frequency receiver that takes radio frequencies and turns it into direct current. 4 germanium diodes, 1, 2, 3, 4, 2 small electrolytic capacitors on the bottom there, and 2 ceramic caps up top. And I'll go outside and show you what this is capable of doing. Here we are again with BackRoomLabs. Here is a project update. I have strung the antenna way up, that sun's kind of in the way, up there to the peak of that star. There's a PVC pipe up there so it's not touching any metal, and the line runs all the way back down there, coming into the Tesla circuit here. I'm not sure what germanium diodes these little guys are here. Pulled them out of a radio, so I'm not sure of their values. But here is the circuit going into a ground that is not very deep. I need to get a copper rod and drive it about 8 foot in the ground for this to be the appropriate ground. But this is about 18-20 inches deep. Circuit's been hooked up for about 5-10 minutes now, and she's up to 2.3 volts. Now, with the appropriate ground, this circuit should get up to about 6 volts, 7 volts of charge. And then what you do is you get a piece of copper plate that is about 2 foot by 4 foot. You get that super hot with a torch, so the whole thing's pretty much red, and then you squelch it, get it super cold. And then that will pretty much ionize it, and then you'll use that for your antenna up top, and that'll get your voltage up to around 12 to 14 off of this. And then what you do is you wrap a special coil that you'll put over the ground that'll go in between the antenna and the circuit in this area. It'll be in series. It'll be a special coil that I gotta wrap, and that'll jump my voltage up to around, we'll say somewhere in the 200 to 215 volt range. And then after that happens, I charge capacitor banks, and then I can run the Bendini motor. And that's where we're at now. It seems to leveled off right there at about 2.3 volts. Oh, goes a little more. But that's a quick update. You see the system is charging the capacitors, and that's a good sign. Alright, we'll check back in. Thanks. How you doing? Here we are with the update on the Tesla solar charger. Here's the meter on voltage. I'm going to go ahead and hook up my negative. I'll hook up my positive. And we got a reading of around 14 volts. This is not a very sensitive meter, so it's going to have some current draw. It'll actually draw the circuit down. That's why you see the voltage going down now. But this has been on for, let's say, an hour and a half. We got up to around 14 volts. There she goes. So that's a quick update. It shows the circuit does work. It does produce power. And that's where we're at. Thank you. Alright, BackRoomLabs is back again. I got my little LED light. And watch this. This is going to show work. See that? Let's give it about an 8-second count. 1, 2, 3, 4, 5, 6, 7, 8. And nothing that time. Let's give it a little bit longer here. Let's give it about 15 or 20 seconds. Alright, here we go. What the hell? Now you're going BackRoomLabs back here, guys. Just a quick update on our little Tesla charger here. There goes the wire way out there to that piece of PVC. Goes back down here to the simple circuit. And here I got, this is aluminum, and that's my ground. That's a little aluminum I-beam. It's about 4 foot into the ground. I'm going to upgrade this to copper. And I found you can put some iron filings and some sort of salt in there, and that'll give you a super good ground. But just here, let's see,
We got our meter hooked up here, a couple alligator clips. We'll check the voltage on this now. This cap has been charging for about 4 days now, so it should be fairly good and charged. Alright, let's see here. There's one guy there. We'll bring the other one over here. Okay. Oh, let me get that on there. Good. Alright. Now, there we go. 20.13 volts. Pretty interesting. I have some more germanium diodes on order, but they ship from China, so it's going to be a while before they get here. I got enough coming to make about 6 more of these circuits. What I'm going to do is I found some ways you got to make a better antenna. You get some copper plate, heat it up, and then squelch it. That'll align the atoms in there to make a better conductor. And then you insulate it and acid wash it, and that kind of pickles the surface of the copper, and it allows it to receive way more of the frequencies that are on the radio bands. Because that's what this is doing. It's picking up radio frequencies from cell phone towers, radio stations, ambient energy from the electrical lines, radio frequencies from our sun, background noise from space. So even if humans weren't producing the radio frequency waves, they still exist, regardless of anything that we put out. We get enough from the sun to make all this work. So basically, I'm thinking if I put 5 or 6 of these together on 5 or 6 antennas, I should be able to have a pretty steady voltage at a pretty decent current. At least enough to power a jewel teeth circuit, maybe power some charge up some super caps, and run some jewel thieves off of those type of things. But I think this, in combination with the crystal batteries, which I got the rest of those made up already, and I'm letting those hydrate. And I'll have an update on those here soon, but this is where we're at here, just to show that this little circuit does work. It will charge a capacitor, and I'm sure if I hook some LEDs or something up to it, I'd at least get some light out of those for a while until that cap died. But that's where we're at. Thanks, guys.